Today's we continues a new topic. Numerical method is concerned the interest of finding the roots of a function in the subtopic of iterative method. When we are in lower form, we learn the method how to determine the roots of an equation. We learn the methods such as analytic method and graphical method, especially the quadratic function and cubic function. We apply the analytic method. We let the f of x equal to 0. Then we dig the working solution. Finally, we can get the x value. Or in graphical method, just do observation on the graph. We can observe at the point x-intercept when f of x equal to 0 or y equal to 0. Another method can be used to find an approximation root of the function is iterative method. What is iterative method? Let's say we have a function f of x equal to 0. Then we create a new function in the form x equal to g of x. The purpose is to obtain a new approximation to the solution. An initial estimate value of x is applied to the function x equal to g of x. Then we generate a sequence of approximation x1, x2, x3 until we get a most accurate answer. How to create a new formula x equal to g of x from the equation given. First, we let the f of x equal to 0, mean the function in the form x squared minus 4x minus x equal to 0. Next, we rearrange the equation until we get the answer in the form x equal to 1 plus 11 over x minus 3. The new formula x equal to g of x we create at the previous working solution can be reinforced into recursive formula x sub n plus 1 equal to 1 plus 11 over x sub n negative 3, where n equal to 0, 1, 2, 3. The recursive formula is iterative formula we want to apply at the next working solution. And initial value x0 equal to negative 1.5 is substituted into the iterative formula. Now we apply the iterative formula to get the approximation solution. When n equal to 0, now we get the x1 equal to 1 plus 11 over negative 1.5 negative 3 equal to negative 1.4444. We do the same calculation, and now n equal to 1, x2 equal to 1 plus 11 over negative 1.4444 negative 3 equal to negative 1.475. We do the same process until we get the answer negative 1.46 for 3 significant figures. The strategy we apply to conclude that the iteration we form is convergence or divergence. First, we have to find the first derivative of the function g of x. From our working solution, apply x or first derivative of g of x equal to negative 11 over bracket x minus 3 to the power of 2. Next step, we do the substitution. We substitute the x sub 0 equal to negative 1.5 into the first derivative of the function g of x. So you get the answer is a negative 0.5432. That is in between negative 1 and 1. So we can conclude it, the function of the iteration is convergent. How to find the approximation when we apply the iterative formula? The working solution x, first we convert the function f of x equal to 0 into the form x equal to g of x. Then we will rewrite the formula we form into the iterative formula x n plus 1 equal to g of x n, where n equal to 0, 1, 2, 3, and so on. That is same as recursive formula. Next, we do calculation for the x value one by one until we get a approximation which and close to the actual value of the root. To conclude whether the iterative formula we form is convergence or divergence, the conditions must be satisfied is the modulus for your first derivative for the g functions must less than 1. Try to solve the exercise below. First part, show that the equation x to the power 3 negative 5x plus 1 equal to 0 has a real root in the interval 0 and 1. For this part, we apply the intermediate theorem to solve the problem. Second part, the iterative formula derived from the above equation can be written in the form x n plus 1 equal to cubic root 5xn minus 1 or xn plus 1 equal to 1 over 5 bracket xn to the power 3 plus 1. Show that the only of this formula can be used to find the root using initial value equal to 0.5 and hence determine this root correct to 4 decimal place.